Good morning everyone. So this is the last topic of Laplace transform, which is known as the convolution theorem. So it says that Laplace of f of x multiplied by Laplace of g of x is same as Laplace of 0 to x f of x minus t g of t dt. Or you can say that Laplace inverse of Laplace of f of x, Laplace of g of x can be easily computed if we know f of x and g of x. For example, consider the problem Laplace inverse of 1 by p square plus 1. You can solve it using partial fraction also, but you can also use the convolution theorem because it is the multiplication of Laplace of f of x and Laplace of g of x. Now we know that what is Laplace inverse of 1 by p square and 1 by 1 plus p square. From there we can easily compute f of x, g of x, and then using the convolution theorem we could have the required answer. So f of x is x and g of x is sin x. Hence Laplace inverse of 1 by p square plus 1 is 0 to x minus t, because f of x minus t is there. So f of x is x, so f of x minus t is x minus t sin t dt, which can be easily solved. Now let us consider the second problem, which says that find the elementary function. So mainly we need to find the Laplace inverse of pi by 2 minus tan inverse p by p square plus 2p plus 5. Yes, if you see this one, or if I break it into the problem, it does not look trivial to find the Laplace inverse of pi by 2 minus tan inverse p. So spend some time and think that how can you find the Laplace inverse of pi by 2 minus tan inverse p. Yes, this is very interesting question. So if you see this one, then I can recall that what is tan inverse p. So tan inverse p is pi by 2 minus tan inverse p is integration p to infinity 1 by 1 plus p square dp. Yes, now let's think how do you proceed. 1 by 1 plus p square is the Laplace of sin t. So it will become integration p to infinity sin t dp. Laplace of sin t dp. Still it is not resolved. Now recall the theorem Laplace of f of x by x. So this would become Laplace of sin t by t. Very interesting question. It can be asked independently also. Find Laplace inverse of pi by 2 minus tan inverse p, which comes out to be, or pi by 2 minus tan inverse p comes out to be Laplace of sin t by t. Yes, it means Laplace inverse of pi by 2 minus tan inverse p is sin t by t. Now it's very easy to compute Laplace inverse of 1 by p square plus 2p plus 5. We did it many times. So you can write it as 1 by p plus 1 whole square plus 2 square. And for Laplace inverse, I need to introduce the exponential function e raised to the power minus t, because p plus 1 is there. And it is p square plus a square, and in the numerator I need a. So I divide it by a also. That's why it becomes 1 by 2 e raised to the power minus t sin 2t. Similarly, let's try one more question. Again, it's not a trivial question. Both the parts are not easy. You need to find Laplace inverse of cot inverse pi by 2 minus ap separately, and Laplace inverse of log a1 plus b square minus a square by p square plus a square. And because of convolution theorem, you can write Laplace inverse of f of p g of p as f of x g of x. Yes, so let's try to find them. Again, spend some time, think over it, that can you find them or not. Now cot inverse pi by 2 minus ap does not look trivial, nowhere. But try to differentiate it and see. If you differentiate it, if you call it f of p, if you differentiate it, you will get f dash p. Yes, which is d by dp of f of p. Now recall that what is the relation by d by dp of f of p and f of x. So Laplace of minus x f of x is f dash p. It means I can easily get the value of minus x f of x by taking the Laplace inverse of f dash p. Try to compute it and match the answer. So f dash p can be computed, which is Laplace of minus x f of x, and now you can see that it is, when you try to find, there is exponential function, so e raised to the power pi by 2ax would come, and this is 1 by a, instead of a it is 1 by a, and something like p square plus a square, so that would become sine x by a. So that's why you will get minus x f of x is equal to e raised to the power pi by 2ax sine x by a, and you can take minus x on that side, that gives you f of x. Now in the same way, try to compute g of x. Again differentiate it and see, try to do it by yourself. So if you differentiate g dash p, this is how it turns out to be. Now you need to use the partial fraction to solve it further. By using the partial fraction, it turns out to be 2 p by p square plus b square minus p by p square plus a square, and which is Laplace of cos bx minus Laplace of cos ax, and it is minus x gx because it is Laplace of minus x gx. If I take Laplace inverse on both the sides, so I will get minus x gx as this one. From there I will get g of x. So I have both f of x and g of x. So this completes the chapter Laplace transform. Thank you.